Hey guys, apologies for slacking on some videos, but I'm gonna get a bunch uploaded. So we're looking at having up to chapter 7 on test 2. And I'm looking around the first, well, around April 7th will be test 2. So we still have plenty of time to cover all these chapters or sections. And I will be extending the homework from 4.0, the one on correlation and chapter 5, etc. So if you're worried about getting them done, have no fear. I'll push them out. I made an announcement about test 1. Um, you guys did really well. It was good to see. And yeah, so if you have any questions about your exam, your score, whatever, partial credit, please send me a message and I'll talk to you about it. Um, so here we go. I think this is a really awesome section. Um, it's super meaningful. I'll try to do my best to explain why it's an important concept. And we're talking about correlation. And the variable in statistics that represents correlation is little r, okay, little r. Um, so I do apologize that this homework had quite a bit of parts. It's kind of hard for me to gauge until I go through it, each question. So you guys will know a ton about correlation. Um, so without further ado, let me start on this question. So essentially what correlation is, and I feel like it's a true example of what statistics is about, is you're essentially trying to see if um, not necessarily random data, the data could be random, right? But you're trying to sift through the randomness um, to discover whether there's something meaningful happening, right? So let me um let me enlarge this, okay? So for data to be correlated, first of all, there has to be a pattern, right? Now, that's too vague, right? Because a pattern could look like this, right? This is somewhat of a pattern. That wouldn't really be considered linearly correlated, okay? So what we're looking for, and you're going to see in a couple other questions exactly what correlation should look like. But we're trying to see if there's enough of a pattern linearly, right? So lines look like this, that, or that, or that. Doesn't matter if it's positive, negative, horizontal. But if there's enough of a pattern that we could use that pattern to predict um, further further data points, right? So is it basically predictive? That's it. So, you know, the nice thing is with Statcrunch, and we can do it by hand. I'm not really going to make you guys do that. But what we want to do is find if the data follows a pattern. Okay, so this you might say, well, yeah, it follows a pattern here, which it does. That's a linear pattern or correlation. And then um, and then there it also follows a pattern, right? The question is, as a whole, what's the pattern? So as a whole, you kind of say, well, it's doing that, right? So that's sort of the interesting part, at least with this one. So there's a way to test correlation, and we'll see that in the next question or two, where there's going to be a table, and based on the number of data points, if the correlation R, little r, by the way, little r can be between -1 and 1. If it equals 1 or equals -1, that's perfect correlation. So that means it completely represents a line. But essentially, what you're looking at with this R when it's calculated is how close is that value to 1? Okay, so if it's close to 1, that means it looks like a line, right? So if I draw a random data set, imagine this, right? Those are my data points. So you can see that there's sort of a linear um, pattern to that. And so we would expect the value of that it's positive slope. So this would be closer to positive one. And we'd expect the value of R to be close to one. Maybe it's 0.9 or 0.95, but the closer it is to one, the more it looks like a line. If my data, let's draw this again. Um, if my data was doing this, let's say, you might say, well, yeah, that definitely looks like a line. And that's the important part. The slope is not the important part. The slope has meaning. It's a negative slope. It's predictive, but to determine whether it's linear or not just depends on how much the data represents a line, okay? And so this would be a value of R that we'd expect to be close to negative one. Negative because it's negative slope, and close to one because it's very much forming a line. Data that doesn't, let's talk about data that doesn't look um, um, like a line, would be kind of like random data, right? Just the data's all over the place. There's no way you could use that random. I know those aren't points, sorry. They look like raindrops, but um, the data is so crazy that you couldn't use it to predict what happens next. In other words, it would be completely random, and the value of R that would go with that would be nowhere near negative one or one. Okay, notice we can't say if this is positive or negative. So we'd expect the value of R to be close to zero, meaning there's no reason to believe that this data is correlated. Okay, and we'll talk about what correlation means specifically, but just know that it's going to be represented by uh, a number R, okay, between negative one and one. Okay, so looking at this one, does the data have a linear relationship? This is a tough question, and it's okay if you get this wrong because sometimes it's not obvious. This isn't the best example. A better example would be something that's either clearly linear or nonlinear. Okay, do the data points lie in a straight line? Okay, so that's what you have to think about for this one. But let's go to a better one. Okay, so you might say they mainly lie in a straight line, but a straight line. uh, it's hard to see here, right? So we would definitely, if we want to make a very educated guess, we would actually calculate R, and then we know we're right or wrong. We can't just always just look and see. Okay, now let's use this example, much better. So match the linear correlation to the scatter diagram. Okay, the scales on the X and Y axis. So let's see, click this. Okay, I think that's what we have, right? Okay. So let's just talk briefly about explanatory and response. Explanatory is like the input or independent, and response is dependent, okay, or the output. Um, let's look at these. So these are our four choices, okay? They're asking which one goes with R's negative 0.946. Now, not only are we interested in that this is a negative number, negative tells us the slope is going down. But what you look at is the number itself and how close it is to one or how far it is from one. And 0.946 is very close to one. That means it's going to be very linear. Option A is very linear, except that's a positive slope, so it can't be this. This one is very much nonlinear. That's no correlation. So this is not it either. This would be an R like these two, probably like C, right? This is the most scattered. This is the only one with a negative slope, so it has to be C. Okay. Okay. Part B, where we have which one corresponds to R equals one. Now, if it actually equals one, that's a positive slope and it's a perfect line. So the only obvious choice is this one. Okay. Positive slope, because this is a positive one, and the closer it is to one, the closer it is to a line. Okay. Now remember, just because this is positive doesn't really mean anything. Yes, 0.025 is positive, but the number is so close to zero or so far from one, it's not going to be anywhere near a line. So notice Notice these two are, even though that's negative, these are much like lines. So these both are close to -1 or 1. These are the only two choices. So really what we're asking is which one is the most scattered, right? So which one's more scattered, A or B? And it's obvious, to me at least, that B is more scattered, right? With A, if you want to wonder or ask about this one, even though that looks scattered, you can see there's a linear pattern to it, right? You could predict that something's going to keep going up, right? This one, we have no idea. The interesting thing about this part is that it's saying that it's slightly positive, meaning there's some kind of reason to believe that it's going to keep going up as you go out. So that one's B. Okay, and then obviously by default, the last one is look at this one because we haven't used this one yet, right? So zero point 0.5 means there is somewhat of a positive linear correlation to that. Um, let's do a similar question. Sorry if you saw that I got that wrong. I just guessed. I didn't open the data set. Okay. So this is a very important problem, and I'm not going to do a bunch of these because they're all going to be like this one. So try to follow how I do question 3 here. So click here to view the data set. Okay. This should be familiar if you've taken any algebra course. X is the independent, so it's the x-axis. Y is the dependent. Now, what's going on here? Well, we want to find this graph. We can do it with Statcrunch. So let's open this in Statcrunch. Let's plot a scatter plot. And we may be able to get it to compute R as well. So we go to graph, we want scatter plot. We tell it our X variable is X, our Y variable is Y. Now let's see if it gives us the option to calculate R along with doing the graph. Let's see. Okay. Let's see. Do, 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 do. Yeah, I think there's a way to do it. You guys can mess with these, but let's just compute it. I'll show you how to calculate R separately. Okay, we get a lovely graph. Notice this doesn't really match. Let me move my screens around. This doesn't really match any options. So this is the graph we have. So there's something wrong, right? Notice the scale of theirs and the scale of ours doesn't match. We go to 2, 4, 8, 6, 6, 8. Theirs are going up to 10. So let's see if we can change that. We may or may not be able to. Um, yeah, so it's a bit of a pain here, but I think the graph's good enough where we can see which one it is, right? So which one we'll kind of have to draw on this to make it look a little better. Let's see. If we were to try to guess, this would look like dot here, and then it goes down here, and then there's two that are stacked on top of each other, and then a third. So roughly, which one looks like that? And you'll see it's definitely not C. It's definitely not A, right? That's close. It's very close, but it doesn't look like this, right? Because this dot and this dot don't match that. So I think it's D, right? D looks the closest. We got it right. Now to calculate R, we'll just close our graph. We're back in Statcrunch. And then we hit stat, regression, simple linear. Linear means we're trying to see how close this is to a line or not. And we just tell it the X variable is X, the Y variable is Y. And then we hit compute. And right here, it gives us a lot of data. Um, we're not going to go into all this stuff, but we do want just R right here. And we see R, the correlation coefficient, is negative 0.091. And that's saying that this is a negative correlation, meaning as you go further out on the X, you expect the Y value to go down. But there's not very strong correlation because we only have 0.091. Okay, let's check this. That's right. Okay. Now I'll do this one because this is annoying and I apologize for these type of questions where it's dropped down and you're like, ah, what's going on? So because the correlation coefficient is negative and the value of the correlation coefficient, the absolute value, so if we just wrote 0.091, get rid of the negative, that's what absolute value is. Now we have to compare it. So we have to open up this critical value table. How many data points do we have? We need to know that 1, 2, 3, 4, 5. So we want to find the one with n is 5. And we see that the threshold is 0.878, meaning any number that we take the absolute value that's below that, that means there's no correlation. If our R value that we calculated was above that, and that's true for all of these, then there is correlation. Okay. So we put our numbers way when we take the absolute value of negative 0.091, it's way lower than that 0.878. So we have to enter that because that's the critical value, 0.878. And ours is less than or not greater. And there is no correlation, right? If this number that we calculated right here or right here was greater than this, then there would be a positive correlation or negative, depending on whether it's positive or negative. But it has to be bigger, the absolute value. Okay. That's that one. This is a good question. So this is just getting you to think about does one thing have a relationship or relation to the other thing? Okay. So for instance, do you think the number of doctors, sorry, does number of doctors correlate to the number of administrators in the hospital? That's a tough one. Now, the hard part is this about this is going to be negative, positive, or no. What that means is as the number of doctors increases, if it was positive, would we expect the number of administrators to increase, right? So you have doctors, administrators, admin. So as doctors goes up, meaning this goes up, does admin go up? That would be positive. Or do we expect the opposite as doctors go up, do admins go down? That would make no sense, right? The more doctors, you need more people to kind of oversee, bills and patient stuff, hospital, all that stuff. Um, so we would expect now you could argue several different ways, but think reasonably. It's reasonable to expect that as the number of doctors go up, number of administrators go up. So we'd say positive. No correlation wouldn't make sense because what if I had 1,000 doctors? So you're telling me that there's not more administrators in that case? No, there has to be, right? So this has to be positive. Now, here's where it gets tricky. Now, outside temperature and number of people wearing coats, you could get sucked into thinking, well, that's going to be positive correlation. But think about it. Here's temperature. Here's number of people wearing coats. Um, let's see. Is that wrong? Is it supposed to be, maybe it's supposed to be this. For this to make sense, I think, right? Maybe it's this. People wearing coats, temperature. In other words, um, as people wearing coats goes up, we expect temperature to go down. Okay. Now, if we did it the other way, what would happen? If we put temp down here, coats, we would say the lower the temp, the more people wearing coats, which would still be a negative correlation, right? So no matter how you phrase it, it's going to be a negative correlation, okay? Right? Unless people are crazy and they like to be like polar bears and whatever. So you guys are good at gaming this. So you're going to guess what? We're going to guess there's no correlation because we haven't used that option, but let's see why. This one's not a good example. No correlation typically means it just doesn't make sense to associate the two. And this is an example. Now, even though heating is inside a house, it's inside your living room, and so is a TV, they don't relate to each other. If I get a really big TV or a very small TV, that's not going to change what my heating bill is. You might think, well, oh, bigger TV means hotter room, but that's not what it's saying. A heating bill doesn't mean your room's being heated up by your TV. It just means your house is being heated. Anyways, okay. I want to do a couple more of these. I know there's a lot, and you guys are gonna hate this section, but it's a really, really important one to get. Okay, so um the explanatory variable, remember, is the independent. Okay, so it's usually going to be this one on the left. So we would say the explanatory variable is the commute time, and the response variable is the well-being score because um, commute commute time effect. So let's go with A. Let's see, it's right. Okay, don't worry too much about that. This part's a little more important. So we're going to have to use this table at some point. That's going to tell us whether this is linear or not. Now, if you're good, right? If you're good, you can kind of look at this table and say, hey, is this going to be positive or negative? Meaning, as we increase commute times, this one's mine. And yeah, I'd say I don't like commuting, so my well-being score would be lower than people with short commutes. Anyways, um, we can see that the well-being scores are dropping, right? So we'd expect a negative correlation. So even without graphing this, I know it's not this one. I know it's not this one. Those are not negative. It's either C or A. Now, we're going to try and hope that Statcrunch does a better job of making a scatter plot for this one because the last one wasn't really scaled correctly, so we just got to get scaled right. So stat, regression, simple linear. Okay. My X variable, now this is where it requires some skill. The explanatory is the X variable, so that's commute time. The response variable, which is wellness score. Hit compute. Can I get it to plot? Just wondering if it will plot the R value, but I don't think it will. Hit compute. Oh, I didn't want this, but there's our R. We'll save this for later. But you can see negative 0.99. That's perfectly linear, so it's probably, no, they both look linear, A and C. But let's see. I'm supposed to graph this. So graph, regression, sorry, scatter plot, X variable, commute, Y, score, and we can't get it to enter R here. We already know R is negative 0.99. Okay. A little tricky, right? Notice that it's not scaled perfectly. So we're sort of left to do our best to match these. You can see though, I'll tell you how you can tell the difference. Notice our last point here, our eighth point, even though it looks like it hits the x-axis, this is only at 64. In this one, A actually hits the x-axis. This is probably the right graph because you can see this is about 64. In this case, Statcrunch actually matched it with the right one. So the answer is C. Okay, so check that. Okay. And then calculating R, we just did it. We just go stat, regression, simple linear. This is the only annoying part is clicking the X and clicking the Y, but it's not bad. And we get negative 0.996 to 3 decimals. And that's it. It's as simple as that. Now, I could show you guys how to calculate R. The formula is not too crazy. I'll open view an example and show you. I believe. Oh, negative. What did I do wrong? Oh, I didn't put a decimal place. Great. Negative point, not negative 996, negative 0.996. Okay. But I'll show you how to compute it. So if you open this, and it just flashed the formula up there. It's not a lovely formula. It's much like the standard deviation formula. Um, and it's just one of those things like, what's the point of making you guys do all this extra work by hand? So yeah, you have to calculate the standard deviation for the left column, standard deviation for the right, as well as the mean. And for each value, let me show you. For each value, so this is a tough calculation to do by hand. I definitely won't ask you guys to do this on a test by hand. You can use Statcrunch, but um, So let's say I knew that the mean of this was, I don't know, 38, and the mean of this is 65. Then for each value, I'm doing this. 8 minus 38 divided by, I don't know, the standard deviation is 5.2, right? I'm just making numbers up for that, but you get what I'm doing. 68.9 minus 65 uh, divided by the standard deviation. Let's say standard deviation, this is like 1.1, all divided by n. So each time you multiply these, and it just gets crazy. So I don't want you guys doing this by hand, but it's a really, really important concept to understand. So, all right, and I'll let you guys do this last part. But let me just show you the rest of the questions. I know it's a lot, but I think it's a good, really good topic. So this is sort of the same thing we just did. First, you're going to make a scatter plot. So open in Statcrunch. But like I said, keep an eye out. Do you think you could do this visually, right? This won't be hard because there doesn't seem to be any change in the head circumference. So that's going to be tricky. Um, and then you calculate R, and that's pretty much it. Now, this last part is a little annoying, so just to give you a heads up, what I want you to do is take these first four, convert them to centimeters, and so you're converting, let me highlight it. You're converting these four and these four to centimeters, and then redoing it. Okay. What it's going to show you most likely is that when you calculate the correlation again, it won't really change much. Okay. Um, all right. So question 7, sort of the same thing. We have some data. What is it's about black bears? It's kind of cool. That's why I love Pearson. It's like keeps it interesting. It's asking something interesting, and you can think about it. Would there be correlation or expected correlation as bears get it's hard to imagine measuring a bear's, I guess, height, but they're calling it length. But think of a bear stood up, I guess. Bears are on all fours or they can stand. Um, would you expect the longer the bear is, the heavier it is? I would say yes, absolutely. Okay. Now be careful here because in this one you can see the data is not actually ordered based on lowest length to greatest length. So you might think, oh, there's no correlation, but there most definitely is. It wouldn't make sense for all these bears to get skinnier or no change to happen as they get longer. You'd expect them to get bigger. Okay. And then what you're going to do is calculate um, calculate the R coefficient, probably a scatter plot, and then answer a question. Um, so not too bad, but again, I apologize that some of these have so many parts. It's just how these problems are. More data. Now, this is not really descriptive of anything, right? It's just random data, but that's sort of how data can be. What the point is that we're trying to determine whether there's any correlation. What that means is if you just looked at this data set, it may be thousands of data points or hundreds, really of two tables. A human is not going to see it. Even AI might not see it, right? I know everyone's into AI. Um, but a statistician knows how to filter that out and find it. Okay. So the first thing, if you notice, what should be done if we were doing this by hand or on a computer is we should organize this. This is not organize these two greatest. Okay. And then calculate R and so on. Okay. So that's that. So all of these can be done in Statcrunch. Please do them in Statcrunch. This one has a ton of parts. I'm sorry. I feel bad. But um, let me just point something out on that one. The first data set is just this one, so make sure you don't do all of them at once. It's just asking about the first two columns here, data set one. Okay. Going on, more data. I know you're gonna be sick of this, but is there correlation between stocks and their rate of returns? you decide, right? So this is definitely asking about long term, not just 2 years, 3 years. It's asking 10 years, what was the best stock, etc. Right. So sometimes you can just look and tell. Sometimes you actually have to get the calculation done to see. So you can't argue that this is not relevant. This is super relevant. Now, what would you think? This is a great question, and this is sort of the heart of why we're learning this topic. Sometimes it's not obvious, but let's say there was data collected on Lyme disease and drowning. What we have to go in is, as scientists, we have to go in with the assumption that we don't know. If we assume something, if we assume we know, we might be wrong. But we have this data, right? I don't know who does this. I don't know who's out there interviewing people with Lyme disease and saying, "Did you drown?" Right? You can't really do that. You can't, so, um, but which one would correlate? Would people drowning correlate with Lyme disease, or would people who have Lyme disease maybe correlate with drownings? It's much more logical to think of asking if Lyme disease affects the number of drownings, right? That's something that we have to just do like naturally as humans is filter that out and say, okay, that makes more sense. So it's definitely not A, right? It wouldn't make sense that the number of drownings means people had Lyme disease. But um, what do you think? What's reasonable to think here? Would people who have Lyme disease be more likely to drown? Or I guess this is deer. This could be deer too. Um, but um, anyways, we don't want to just guess. We don't want to tell someone, yes, there is or no, there isn't. We would say, well, the data says this, right? So the data is going to speak for itself. And all we need to do is open that data, right? Who cares about months for this? I don't think we need that. We just want to know cases, drowning deaths. Okay, so it's important to know which ones are X. That's going to be Lyme disease. Let's make our scatter plot. Our X is Lyme disease, and our Y is drowning deaths. Okay. Oh, what did we miss? Didn't click it. Drowning deaths. All right, compute. Okay. Which graph matches? It's not D. It's either B or C. Looks like it's right. Looks like it's C, right? Let's see if that's right. Okay. Now we want to calculate R. But before we do that, and this is where I'm going to end the video because I need to make others. Do we expect, first of all, is R going to be positive or negative? Certainly, it seems to be going up. So R is positive, right? It's positive. How close is that? Can't even spell. How close is that to 1? It's very close, right? So before we even calculate, we know the answer is positive and probably like 0.95, 94. Regression, simple linear. X is Lyme disease, Y is drowning deaths, and I get R is 0.963. Okay. Now you kind of see that stats is meaningful and interesting. It's kind of cool. Now the important part of this is not that, oh great, we got all the answers right. No. It's that tells us there is a connection, right? We're not going to reject this. Look at this. We have how many data points? How many data points was that? 10, 11, 12. So we go to our critical value table, look at 12. As long as the R is greater than 0.576, that means there's correlation. We're way higher than that. Okay. So that's that. All right, guys. I hope this helps a ton. Um, I'll make some more today. I'll probably make like 10 videos today, but please let me know if these are helpful, and if you need any help, just let me know.